World electricity generation by source in 2018. Total generation was 26.7 petawatt-hours. A gas-fired power plant or gas-fired power station or natural gas power plant is a thermal power station which burns natural gas to generate electricity. Natural gas power stations generates almost a quarter of world electricity and a significant part of global greenhouse gas emissions and thus global warming. However, they can provide seasonal dispatchable generation to balance variable renewable energy. Where hydropower or interconnectors are not available, a gas-fired power plant is a type of fossil fuel power station in which chemical energy stored in natural gas, which is mainly methane, is converted successively into thermal energy, mechanical energy and, finally, electrical energy. Although they cannot exceed the Carnot cycle limit for conversion of heat energy into useful work, the excess heat may be used in cogeneration plants to heat buildings, produce hot water, or to heat materials on an industrial scale. In a simple cycle gas turbine, also known as open cycle gas turbine, hot gas drives a gas turbine to generate electricity. This type of plant is relatively cheap to build and can start very quickly. But due to its lower efficiency is only run for a few hours a day as a peaking power plant. CCGT power plants consist of simple cycle gas turbines which use the Brayton cycle, followed by a heat recovery steam generator and a steam turbine which use the Rankine cycle. The most common configuration is two gas turbines supporting one steam turbine. They are more efficient than simple cycle plants and can achieve efficiencies up to 55% and dispatch times of around half an hour. Reciprocating internal combustion engines tend to be under 20 megawatts, so much smaller than other types of natural gas-fired electricity generator, and are typically used for emergency power or to balance variable renewable energy such as wind and solar. Gas-fired power stations emit about 500 grams of CO2 per kilowatt-hour of electricity generated. This is about half that of coal-fired power stations but in general more than 10 times that of nuclear power and renewable energy. Life cycle emissions generally show a similar pattern, unless skewed by methane emissions such as from gas leaks. As of 2019, very few power plants have carbon capture and storage or carbon capture and utilization. Gas-fired power plants can be modified to run on hydrogen and according to General Electric a more economically viable option than CCS would be to use more and more hydrogen in the gas turbine fuel. Hydrogen can at first be created from natural gas through steam reforming, or by heating to precipitate carbon, as a step towards a hydrogen economy, thus eventually reducing carbon emissions. Sometimes a new battery storage power station together with solar power or wind power is cheaper in the long term than building a new gas plant, as the gas plant risks becoming a stranded asset. As of 2019, a few gas-fired power plants are being retired because they are unable to stop and start quickly enough. However, despite the falling cost of variable renewable energy, most existing gas-fired power plants remain profitable, especially in countries without a carbon price, due to their dispatchable generation and because shale gas and liquefied natural gas prices have fallen since they were built. Even in places with a carbon price, such as the EU, existing gas-fired power stations remain economically viable, partly due to increasing restrictions on coal-fired power because of its pollution. Even when replacing coal power, the decision to build a new plant may be controversial. List of natural gas-fired power stations in the United States.